In this video, we will discuss how to find the least common multiple of two numbers. I will first go through a few basic examples and then an example ACT problem. So here, if I wanted to find the least common multiple of 4 and 5, I can go through all the multiples of 4, which would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, and 4 times 8 is 32. I'll go with the 5s. Multiples of 5 include 5, 10, 15, 20, 25, 30, 35. So the least common multiple is where they both have a common multiple. The first one that we encounter. So we look at that, that's going to be 20. They both have 20 is a common multiple. And that's the least one, the first one that we encounter. If we continued these, 4 times 8 was 32, 4 times 9 is 36, 4 times 10 is 40, and after 35, that's 7 times 5, 8 times 5 is 40, so that would be the next common multiple, but that's not the least one. 20 is the least common multiple. So instead of running through the multiples of each number and seeing which one's in common, we can use a different method that utilizes the prime factorization of each number. If I look at 12, if I were to make a factor tree, I can do 3 times 4. 4 breaks down into 2 times 2. So we have 2 squared times 3. I'm just looking at the numbers that don't have any numbers underneath them. If I look at 18, it can become 2 times 9. 9 breaks down to 3 times 3. So that's going to be 2 times 3 squared. The 2 here and 2 3's. Alright, from there I'm going to take each factor. I have a 2 and 3. I'm going to take the highest exponent of each one. I have a 2 squared, so that's going to be 2 squared here. 3 squared is the highest one. So I'll have 2 squared times 3 squared, or 4 times 9, or 36. So 36 is going to be our least common multiple. So here I found the prime factorization of each. I'm going to take all the numbers, not the ones they have in common, but just all the factors 2 and 3. In this case, they were the common ones, but you always want to take all the different factors and take the highest exponent of each one. So we had 2 and 3. Highest exponents were 2 squared and 3 squared. So we multiply those together to give us 36. So 36 is the least common multiple. So in this example, we want to find the common multiple of 24 and 90. Again, I want to find the prime factorization. So 24 can be 2 and 12. 12 can become 3 and 4. And 4 is 2 times 2. So I have 3, 2, so 2 to the third times 3 to the first. Ninety can become 9 and 10. 9 is 3 and 3, 3 times 3, and 10 is 2 times 5. So that becomes 2 times 3 squared times 5. So I'm going to take all the different factors. We have 2, 3, and 5. I take the highest exponent. Highest exponent for the 2 is 2 to the third. For 3, we got 3 to the second. And for 5, 5 to the first. I'm going to multiply those all together. So that's going to be 8 times 9 times 5, which gives you 360. So 360 is going to be the least common multiple of 24 and 90. Alright, so now let's take a look at an example ACT problem. So this one reads, the least common multiple, LCM, of two numbers is 216. The larger of the two numbers is 108. What is the greatest value the other number can be? So for this one, I want to take the 216 and do the prime factorization of that, which can become 8 times 27. And 8 is 4 times 2. And 4 is 2 times 2. 27 be 3 times 9. 9 is 3 times 3. So we have 2 to the third times 3 to the third. If I look at 108, that is 4 times 27. 4 becomes 2 times 2, 27, 3, and 9, and 9, 3, and 3. So that's 2 to the second power times 3 to the third power. So I compare the 216 to the 108, and they both have 2's and 3's. 3 to the third, they have the same amount there, and 216 has the 2 to the third, and 108 has 2 to the second. So we can have another multiple. So our second number can utilize the 2's and 3's. So both of these, the 216 and 108, both have 3 to the third power. So my other number won't have that much. It's going to have 2 to the third power times 3 to the second. Because basically the 3 to the third, I already get the max there in the 108s. So I can't make another number. It'd be 3 to the third times 2 to the second. So if I would have chose 3 to the third, 108 already has 2 to the second, so it had to be 2 to the first, which would give you 2 times 27, which gives you 54. But is that going to be the largest one? So let's say I decided, 3 to the second, we're going to take that. But then I can use 2 to the third, 8 times 9, which will give you 72. So I need to have combinations of the factors 2 and 3. 108 is our largest number, so the other number had to be smaller. I couldn't use 3 to the third really because 108 already had that, and it already has the 2 to the second, so I had to choose 3 to the third and 2 to the first, which only gives me 54. But if I use 2 to the third and only 3 to the second, it gives me a bigger number of 72. So our answer here is 72.